Welcome to another exercise in the workbook statistics. This time with an exercise focusing on coefficient t-test and the f-test from overall model quality. So let's have a look at the exercise. For 5 selected whiskies, the price y and the age x is considered. The result of a linear regression is the following equation. And we get this one here. So we see it's a classical simple linear regression with one independent variable. Our first task, assuming the coefficient of determination r squared of the estimation is r squared equal to 0.92. Conduct a suitable test to check whether the model has significant explanatory power, then with an additional comment, at an acceptable margin of error of 5%. The second part, argue why an increase of the acceptable margin of error, for example 10%, will not change the result from part A. So let's do first off the part A. Here we have to conduct an f-test, and for the f-test we first off need the test statistic. This one, however, can easily be calculated. It's simply r squared, the coefficient of determination, which we have at 0.92, divided by k. K is the number of independent variables, the number of x variables in the equation. Well, it's a simple linear regression, so we only have one independent variable. So we're going to divide this by 1. Then we have 1 minus r squared. So that's simply only the 8%, which are left here. And we divide this by n minus k minus 1. N, in this case, is 5 observations, 5 whiskies, minus k minus 1 minus 1 more. So we have 3 here, 5 minus 1 minus 1. If we calculate this, we get as a value 34.5. So that's our test value. Now we need to have a reference value to compare this test statistic to. This reference statistic for the f-test is given as f k n minus k minus 1, 1 minus alpha. Well, the k we know from up here, that's 1. Then we have n minus k minus 1, that's a 3 from down here. And we have 1 minus alpha. In this first part, alpha was supposed to be 5%, so 0.05. If we subtract this from 1, we get 0.95. So we look up in the table for the f distribution, the value f130.95. There we find a value of 10.128. So that's our reference value. And for the test itself, we simply compare test and reference statistic. In this case, we see the test statistic is much larger than the reference statistic. So we can reject our H0 hypothesis. And H0, in the case of an f-test, means the model has no significant explanatory power. So here it's the opposite. Our model has significant explanatory power. So much for the first part. In the second part, part B, we had to argue why, if we increase our margin of error, the results will not really change. So if we increase the margin of error from 5% to 10 or 20%, why the result will not change. The mainly important aspect to consider here is whenever we increase the margin of error, we will get a smaller reference statistic. If we get a smaller reference statistic, however, means it's much easier to actually reject our H0 hypothesis. Well, since in this case, the test statistic is already larger than the reference statistic, and we decrease the reference statistic even more, well, it still remains larger than the reference statistic. So in this case, we can say, since we already have a significant result, the result will remain significant as long as the margin of error is only increased. If this were to be decreased, then this might be a whole different story. But with an increase in the margin of error, if the test is significant at one point, it will remain so. And well, that's then everything there is on this part and on the whole exercise. I hope you enjoyed it. I say goodbye and see you next time.